There, back to planning performance domain. The planning performance domain addresses activities and functions associated with the initial, ongoing, and evolving organization and coordination necessary for delivering project deliverables and outcomes. Effective, execu- Effective execution of this performance domain results in the following desired outcomes. The project progresses in an organized, coordinated, and deliberate manner. There is a holistic approach to delivering the project outcomes. Evolving information is elaborated to produce the deliverables and outcomes for which the project was undertaken. Time spent planning is appropriate for the situation. Planning information is sufficient to manage stakeholder expectations. There is a process for the adaptation of plans throughout the project based on emerging and changing needs of conditions. And here we're going to go into a couple of key terms. Estimate, a quantitative assessment of the likely amount of outcome of a variable, such as project costs, resources, effort, or durations. Accuracy, within the quality management system, accuracy is an assessment of correctness. Precision, within the quality management system, precision is an assessment of exactness. Crashing, a method used to shorten the schedule duration for the least incremental cost by adding resources. Fast tracking, a schedule compression method in which activities or phases normally done in sequence are performed in parallel for at least a portion of their duration. Budget, the approved estimate for the project or any work breakdown structure, component, or any schedule activity. The purpose of planning is to proactively develop an approach to create the project. Deliverables. The project deliverables drive the outcomes the project was undertaken to achieve. High level planning may begin prior to project authorization. The project team progressively elaborates initial project documents such as vision statement, project charter, business case, or similar documents to identify or define a coordinated path to achieve the desired outcomes. The amount of time spent planning, both upfront and throughout the project, should be determined by the circumstances. It is inefficient to spend more time planning than is needed. Therefore, the information gained from planning should be sufficient to move forward in an appropriate manner, but not more detailed than necessary. Project teams use planning artifacts to confirm stakeholder expectations and provide stakeholders with the information they need to make decisions, take action, and maintain alignment between the project and stakeholders. Development approach. The development approach can influence how much, and when planning is conducted. Examples include a specific phase for planning or organizing early in the life cycle. In these situations, much of the planning is performed upfront. The initial plans are progressively elaborated with more detail through the project, but there is little change to the original scope. An approach with high level planning upfront, followed by a design phase where prototyping is used. After the project team and stakeholders agree to the design, the project team completes more detailed planning. Adaptive approaches where the project team conducts iterations. Some planning occurs upfront to establish release plans, and further planning occurs at the beginning of each iteration. Project deliverables. Often the project deliverables necessitate planning in a specific. Construction projects require significant upfront planning to account for design, approvals, materials purchasing, logistics, and delivery. Product development or high tech in projects may use continuous and adaptive planning to allow for evolution and changes based on stakeholder feedback and technological advances. Organizational governance, policies, procedures, processes, and culture may require product managers to produce specific planning artifacts as for the organizational requirements. Market conditions. Product development projects can take place in a highly competitive environment. In these situations, project teams can undertake a minimum amount of upfront planning as the emphasis is on speed to market. The cost of delay that extensive planning entails exceeds the risk of potential rework. Legal or regulatory restrictions. Regulatory agencies or statutes may require specific planning documents before granting an authorization to proceed or to secure approval to release the project deliverable into the market. Planning begins with understanding the business case, stakeholder requirements, and the project and product scope. Product scope is the features and functions that characterize a product, service, or result. Project scope is the work performed to deliver a product, service, or result with the specified features and functions. Predictive planning approaches start with high-level project deliverables up front and decompose them into more detail. This approach can employ a scope statement and or a work breakdown structure to decompose the scope into lower levels of detail. Product projects that use iterative or incremental approaches can have high-level themes or epics that are decomposed into features, which are then further decomposed into user stories and other backlog items. Work that is unique, significant, risky, or novel can be prioritized to reduce the uncertainty associated with project scope at the start of the project before significant investment has taken place. Project teams plan routine work based on the concept of last responsible moment. This approach defers a decision to allow the project team to consider multiple options until the cost of further delay would exceed the benefit. It reduces waste by not expending time in developing plans for work that may change or may not be needed. I like that one. Estimating. Planning entails development estimates for work, effort, durations, costs, people, and physical resources. Estimates are a quantitative assessment of the likely amount of outcome of a variable such as project cost, resources, effort, or duration. As the project evolves, the estimates can change based on current information and circumstances. The project's phase in the life cycle impacts four aspects associated with estimating. Range. Estimates tend to have a broad range at the start of the project where there is not much information about the project and product scope, stakeholders, requirements, risks, and other information. What? Sorry. Estimates tend to have a broad range at the start of the project when there is not much information about the project and product scope, stakeholders, requirements, risks, and any other information. Projects that are well along in their lifestyle may have an estimating range of -5 to +10%. Accuracy refers to the correctness of an estimate. Accuracy is linked to range in that the lower the accuracy, the larger the potential of range of values. An estimate at the start of the project will have less accuracy than one that is developed halfway through the project. Precision. Precision is different from accuracy. Precision refers to the degree of exactness associated with the estimate. For example, an estimate of 2 days is more precise than sometime this week. The precision of estimates should be compatible with the desired accuracy. Confidence. Confidence increases with experience. Experience working on previous similar projects can help with the level of confidence required. For new and evolving technology components, the confidence in estimates is expected to be low. I'm a Okay. Absolute and relative estimating. Absolute estimates are specific information and use actual numbers. An absolute estimate for effort might be shown as 120 hours of work. One person working full time could accomplish the work in 15 days, assuming 8 hours of productivity per workday. While estimates while absolute estimates are specific, relative estimates are shown in comparison to other estimates. Relative estimates only have meaning within a given context. Flow based estimating. Flow based estimates are developed by determining life cycle time and throughput. Cycle time is the total elapsed time it takes one unit to get through a process. Throughput is the number of items that can complete a process in a given amount of time. These two numbers can provide an estimate to complete a specified quantity. Schedule is a model for executing the project's activities, including durations, dependencies, and other planning information. Schedule planning can use predictive or adaptive approaches. Step 1. Decompose the project scope into specific activities. Step 2, sequence the related activities. Step 3, estimate the effort, duration, people, and physical resources required to complete the activities. Step 4, allocate the people and resources to the activities based on availability. Step 5, adjust the sequence, estimates, and resources until an agreed upon schedule is achieved. If the schedule model does not meet the initial desired end date, schedule compression methods are. Crashing is a schedule compression method that seeks to shorten the duration for the least incremental cost. Crashing can include adding people to activities, working overtime, or paying to expedite deliveries. Fast tracking is a schedule compression method in which activities or tasks that are normally done in sequence are performed in parallel, at least for a portion of their duration. Fast tracking often entails applying leads and lags along a network path. A lead is where the work of a successor activity is accelerated, such as starting a successor activity before the predecessor has finished. A lag is a delay of successor activity. An example of using a lag would be changing the type of relationship between activities and then applying a lag. For example, rather than waiting for an activity to finish before the next one starts, a finish to start relationship, change the relationship to have the end of the successor activity finish a determined amount of time after the end of the predecessor, a finish to finish relationship. The network logic would show a lag between the finish of the predecessor and the finish of the successor activities. There is an example of a finish to finish relationship with a lag. A lag can also be applied between the start of one activity and the start of another activity. Gantt charts, very helpful in this. When compressing the schedule, it is important to determine the nature of the dependencies between activities. Some activities cannot be fast-tracked due to the nature of the work. Others can. The four types of dependencies are mandatory dependency, a relationship that is contractually required or inherent in the nature of the work. This type of dependency usually cannot be modified. Discretionary dependency, a relationship that is based on the practices or project preferences. This type of dependency may be modifiable. An external dependency is the relationship between project activities and non-project activities. This type of dependency usually cannot be modified. Internal dependency, a relationship between one or more project activities. This type of dependency may be modifiable. Adaptive schedule planning uses incremental planning. One such scheduling approach is based on iterations and releases. A high level release plan is developed that indicates the basic features and functionality to be included in each release. Within each release, there will be two or more iterations. Each iteration adds business and/or stakeholder value. Value may include features, risk reduction, experimentation, or other ways of delivering or protecting value. The planning for the work in future releases is kept at a high level so the project team does not engage in planning that could change based on feedback from earlier releases. Adaptive approaches often use time boxes. The work in each time box is based on a prioritized backlog. The project team determines the amount of work they can do in each time box, estimates the work, and self manages to accomplish the work. At the end of the time box, the project team demonstrates the work completed. At that point, the backlog and estimates of work available to be done may be updated or reprioritized for the next time box. Determining the schedule involves using the information in the estimating section to determine overall duration and effort. Determining the schedule involves using the information in the estimating section to determine overall duration and effort estimates. Regardless of the scheduling approach used, the relationship between effect and duration needs to be addressed. Some activities are effort driven, which means that the duration can be reduced by adding people. This approach can work up to a point after which adding people might actually extend duration. Framing a building is effort driven. If more people are added, the duration can be reduced. Some activities are fixed duration, such as running a test or conducting employee training. On the other end, if you have too many people framing, They're going to get in each other's way. If you have a huge project, you got to, again, project management's everywhere. This is how they run stuff. Skipping. I'm sorry. The project budget evolves from the agreed estimates for the project. This information in the section here, estimating is applied to project costs. To develop cost estimates. Cost estimates are aggregated to develop the cost baseline. What's up, Bo? The cost baseline is often allocated across the project schedule to reflect when the costs will be incurred. The practice allows project managers to balance the funds. I'm so sorry. To balance the funds approved in a specific budget period with the scheduled work. If there are funding limitations for a budget period, the work may need to be rescheduled to meet those limitations. The project budget should include contingency reserve funds to allow for uncertainty. Contingency reserves are set aside to implement a risk response or to respond to risk events should they occur. Management reserves are set aside for unexpected activities related to in scope work. Depending on the organization's policies and organizational structure, management reserves may be managed by the project, the sponsor, the product owner, or the PMO at the program and portfolio level. Shows the budget buildup. Excuse me. Project team composition and structure. Planning for project team composition begins with identifying the skill sets required to accomplish the project work. This entails evaluating not only the skills, but also the level of proficiency and years of experience in similar projects. There are different cost structures associated with using internal project team members versus securing them from outside the organization. The benefit that outside skills bring to project are weighted against the costs that will be incurred. When planning for the project team, the project manager considers the ability and necessity for the project team to work in the same location. Small project teams that can work in the same room are able to take advantage of osmotic communication and can solve problems as they arise. Some project teams are physically dispersed. Project team members may be in different cities, time zones, or countries even. On projects where project team members work virtually, more time is spent connecting people through technology. Communication. Communication planning overlaps with stakeholder identification, analysis, prioritization, and engagement as described in the stakeholder performance domain. Communication is the most important factor in engaging with stakeholders effectively. Planning communication for the project entails considering the following: who needs information? What information does each stakeholder need? Why should information be shared with stakeholders? What is the best way to provide the information? When and how often is information needed? Who has the information needed? There may be different categories of information, such as internal, external, sensitive, public, or general and detailed. Analyzing the stakeholders' information needs and categories of information provides the foundation for establishing the communication processes and plans for the projects. Physical resources apply to any resource that is not a person. It can include materials, equipment, software, and testing environments, licenses, and so forth. Planning for physical resources entails estimating, as described earlier in this section, as well as supply chain logistics management. Projects with significant physical resources, such as engineering and construction projects, will need to plan for procurement activities to acquire the resources. This may be simple as utilizing a basic ordering agreement. Sorry. Maybe as simple as utilizing a basic ordering agreement, or as complicated as managing, coordinating, and integrating several large procurement activities. Planning for physical resources includes taking into account lead time for delivery, movement, storage, and disposition of materials, as well as means to track down material inventory from arrival on site to delivery of an integrated product. Project teams whose projects require significant physical materials think and plan strategically about the timing from order to delivery to usage. This can include evaluation of bulk ordering versus cost of storage, global logistics, sustainability, and integrating management of physical assets within the rest of the project. Procurements can happen at any time during a project. However, upfront planning helps to set expectations that ensure the procurement process is performed smoothly. Once the high level scope is known, project teams can conduct make or buy analysis. This includes identifying those deliverables and services that will be developed in house and those that will be purchased from external sources. This information impacts the project team and the schedule. Contracting professionals need advanced information on type of goods needed, when they will be needed, and any technical specifications required for the procured goods or services. Changes. There will be changes throughout the project. Some changes are a result of a risk event occurring or a project environment change. Some are based on developing a deeper understanding of requirements, and others are due to customer requests or other reasons. Therefore, project teams should prepare a process for adapting plans throughout the project. This may take the form of a change control process, reprioritizing the backlog, or re-baselining the project. Projects that have a contractual element may need to follow a defined process for contract changes. Metrics. There's a natural linkage between planning, delivering, and measuring work. That linkage is metrics. Establishing metrics includes setting the thresholds that indicate whether work performance is as expected, trending positively or negatively away from expected performance, or unacceptable. Deciding what to measure and how often is best informed by the phase. Only measure what matters. Metrics associated with the product are specific to the deliverables being developed. Metrics associated with a schedule and budget performance are often driven by organizational standards and are related to a baseline or an improved version of the schedule or budget against which actual results are compared. As part of planning, the metrics, baselines, and thresholds for performance are established, as well as any test and evaluation processes and procedures that will be used to measure performance to the specification of the project deliverable. The metrics, baselines, and tests are used as the basis to evaluate variance of actual performance as part of the measurement performance domain. Alignment. Planning activities and artifacts need to remain integrated throughout the project. This means that planning for the performance in terms of scope and quality requirements aligns with delivery commitments, allocated funds, type and availability of resources, the uncertainty inherent in the project, and stakeholder needs. Project teams can require additional planning artifacts depending on the type of project. For example, logistic plans will need to integrate with material and delivery needs, testing plans will need to align with quality and delivery needs, and so forth. Work on one project often occurs in parallel with other projects in a program or a release. The timing of the work of a single project should align with the needs of the work on related projects and the operations work of the organization. Large projects may combine the planning artifacts into an integrated project management plan. For smaller projects, a detailed project management plan will be inefficient. Regardless of how the timing, frequency, and degree of planning, the various aspects of the project need to remain aligned and integrated. Interactions with other performance domains. Planning occurs throughout the project and integrates with each performance domain. At the start of the project, the expected outcomes are identified and high-level plans to achieve them are developed. Depending on the selected development approach and life cycle, intensive planning may be conducted up front, and then plans may be adjusted to reflect the actual environment. Other life cycles encourage just enough planning at various points throughout the project, with the expectation that plans will evolve. Throughout the project, planning guides the project work and delivery of outcomes and business value. Project teams and stakeholders establish measures of progress and success and performance as compared to plans. Uncertainty and planning interact as project teams plan for how to address uncertainty and risks. Plans may need to be revised or new plans developed to account for events or conditions that emerge. The project team members, environment, and project details influence plans to working effectively with the project team and engaging proactively with stakeholders.